All right, boys and girls, here's another type of division problem with fractions. Only this time, when you look at this particular problem, it's kind of flip-flopped. And what I mean by that is now you're starting with a whole number and you're dividing it by a unit fraction. So this is kind of the opposite of the first video. So now when you're looking at this problem, this one to me, I always teach this and I kind of always start teaching it as a pizza problem because I just think it'll click and it'll make sense if you can think of it as a pizza problem. So again, this division stuff, it's kind of weird, it's different, it's new, but if you could think about it in a way that makes sense to you, then it should be a lot easier and you should really understand, how you're getting your answers, and the answers that you get need to make sense. You need to understand why you're getting your answer and how you're getting it, not just, oh, I'm going to get an answer and get it. You need to understand why and how. So the part on this one, and again, anytime I see this setup, I always think of a pizza or pizzas. So in this case, this problem's 3 divided by 1/4. So right off the bat, I'm thinking this is a pizza problem because it starts with a whole number. I have 3 pizzas. And so if I take my 3 pizzas and I simply just cut them in fourths, that's pretty simple. I'm just going to go and I'm going to very quickly cut them into fourths. And it doesn't have to be pretty. I just have to understand what fourths would look like. So it's almost like I'm putting a plus sign through all of them. Basically, what I'm asking myself now is, well, how many fourths do I have? And so once I cut them into fourths, even though they're not pretty, I'm just going to go count them. So I've got a fourth here, 1. I'm going to label them. I've got 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. And so really to answer this problem, I've got 12. And it's because, this is something that kind of throws kids off a little bit. And they're like, well, sometimes I have kids asking me, well, why is it that, we're starting with 3 and we're getting something bigger than what we started with? And that's because when you're doing this problem, this particular type of problem, and you're taking a whole number divided by, in this case, a unit fraction. Again, remember, unit fractions are fractions that have a whole as the numerator. You're basically, you are still splitting something up. You're still doing that action of dividing it. But when you're dividing it by a unit fraction, you're thinking, okay, it's kind of like, well, how many pieces do I have? That's why I think pizzas make sense. Because if you worked at Pizza Hut or Domino's or any pizza place, you're basically, and if your job is definitely cutting the pizzas, you're doing these problems constantly. And so, thinking about this, and that's the thing too, I always tell my students is, not every single problem like this might be a pizza problem, meaning, they might be talking about something completely different. But I just think pizzas make sense, and it makes sense to me, and I think most kids understand pizzas and they can visualize a pizza. And so I always call these pizza problems. So anytime I see a whole number and then divided by a unit fraction, I know that's a pizza problem. And in this case, I know I can already write my answer. My answer is going to be 12. So how to get that though, or how to find it using an algorithm. So we're going to have some of the same things happening here as we did on the other video. We're going to start with, again, this acronym, and I'm going to write it off to the side, your keep, change, flip. You're going to think about keeping your 3. Well, if you keep your 3, then I'm going to think of it as in a fraction form. I'm going to write 3 over 1. It's still 3. I'm just now thinking of it as a fraction. Times, that's my change. I'm going to change the symbol. I'm going to basically do the opposite of division. That's multiplication. So I'm going to change it. And then my flip is going to be my reciprocal, or my flip-flop of my fraction. So I'm going to write this as 4 over 1. Now, if I multiply this across, 3 times 4 is going to give me 12. 1 times 1 is 1. And then I will simply have 12 over 1, or 12 as my whole number, as my answer. So again, it kind of just depends on what makes sense to you. You might think of something completely different. I had a kid one year that was like, hey, could we do this, but it be cakes? Cakes, that makes sense to me because I bake a lot of cakes. And I said, sure, that's perfectly fine. It just depends on how you see it. Um, be creative. Think of something that makes sense to you. And if it makes sense to you, then apply it on every single problem. Like I said, you might read a word problem and it may not be dealing with pizzas or cakes, but I can always think of that. And like I always tell that to my students, there's so many times when I'm working math problems and money comes to mind. Even though it may not be a money problem, it may not be dealing with money, but money makes sense. So I always kind of think of that to help me get through the problem. Same thing here. Think of something that makes sense to you. So I like to call these pizza problems. All right. So this particular problem is going to be the same thing. We have a whole number divided by a unit fraction. So I'm going to show you something similar to the last video, something to keep in mind. If you have a whole number, like in this case 6, and you're dividing it by a unit fraction, you can keep in mind something as you're working. So if you're going to start with the whole number, you should end with a whole number. So I'm already thinking in my mind here, my answer should be a whole number. I should not have a fraction as an answer. So that's something that, it's something you can kind of take with you, especially like on tests. That would be something to keep in mind, especially if it's multiple choice. I mean, you guys get to take multiple choice tests. Why not think about that as you're solving these problems? You're still going to want to show your work. You're still going to come up with the answer, but it's just something to think about. All right, so I'm going to keep the 6. I'm going to write the 6 as a fraction, 6 over 1. I'm going to change the symbol to multiplication, and then I'm going to multiply it by the reciprocal, or I'm going to flip-flop it. So I can now think of 6 times 4 is 24. 1 times 1 is 1. I'm going to get an answer of 24 divided by 1, or simply just 24. So in my mind, if there's 6 pizzas, and then you cut those into fourths, kind of like on the last one, now we just have 6 of them, I'll have more pieces. I'll have 24 of those 1/4 slices. All right, on this last one, again, we're going to think about keeping the 3 over 1, times 9 over 1, keep, change, flip, all is the same thing. The only thing that's changing here are numbers. 3 times 9 is 27. 1 times 1 is 1. 27 divided by 1 is 27. And so for this particular problem, if you had 3 pizzas, but then you cut them into ninths, ninths would be smaller, and so you're going to have more, especially if you have 3 of them. So every time you have a pizza, you'd have 9 slices. So how many total slices do you have? Well, you'd have 27.